Hello, everybody. It is April 9th, Thursday. Section 7.3 and 7.5. We are not going to do 7.4, is on the docket for today. Adding and subtracting rational expressions is 7.3. And then in 7.5, we will solve rational equations. Okay. The first thing we're going to have to do in 7.3 is we're going to have to learn how to find what are called least common denominators of polynomial expressions. And so that being the case, let's just start doing that. So we're going to try to find the least common denominator and we normally abbreviate this as LCD. Okay. Suppose I give you two rational expressions, x over 2 and 3 over x plus 1. Now, what would be the least common denominator of both these denominators here? Well, the least common denominator must contain the greatest number of common factors, or the greatest number of factors that appear in each of the separate denominators. So notice that 2 is already factored. X plus 1 cannot be further factored down. And being the case, therefore, the least common denominator for both these rational expressions is going to have to contain a 2. And our least common denominator is also going to have to contain one binomial factor of x plus 1. Think of it this way. The least common denominator has to be an expression that has to be divisible by all your denominators. So, in order to be divisible by this first denominator 2, my LCD must have a factor of 2. In order for my least common denominator to be divisible by x plus 1, my LCD must have a factor of x plus 1. So this would be the least common denominator of both these denominators here. Let's try another one. All right, what would be the least common denominator of both these rational expressions? Well, notice both denominators are already factored. You want to make sure your denominators are factored completely before you even try to find the least common denominator. In order to be divisible by the first denominator, x plus 2, we must have a factor of x plus 2 appearing in our least common denominator. To be divisible by the second fraction's denominator of x minus 2, our least common denominator, our LCD, must also have a factor of x minus 2. So therefore, ladies and gentlemen, this would be the least common denominator, or the least common multiple, if you will, of both these denominators. So that one is done. All right, we will look at this one next. So what would be the least common denominator of y plus 3 squared and 4 times y plus 3? Well, again, keep in mind, our least common denominator has to be an expression that's divisible by all your denominators. Now, in order to be divisible by both these denominators here, it's not good enough just to have one factor of y plus 3 showing. Because y plus 3 is not divisible by y plus 3 squared. So in order for our least common denominator to be divisible by both this denominator and this denominator, we must have not one factor of y plus 3, but two of them. So when it comes to variables, you always choose the greatest exponent if you do have exponents appearing. So we're going to have two factors of y plus 3 appearing in our least common denominator. But to be divisible by the second denominator, we're also going to have a factor of 4. And so therefore, ladies and gentlemen, this would be the least common denominator of both these denominators. Okay, here's one right here. What would be the least common denominator of both these denominators? Well, it's hard to tell. In fact, it's almost impossible to tell because these denominators are not first factored. We did not have that problem up here with all these other ones. All these other denominators were already in completely factored form. But for the first time, we're seeing two rational expressions where their denominators are in need of factoring. So before we can put together least common denominators of both these rational expressions, we're going to have to factor completely their denominators. So let's look at this first denominator here. What is the greatest common factor of 3x cubed and 12x squared? Well, after some thought, what can be factored out of both these terms is a 3 and also an x squared. So let's do that. So we factor the 3x squared out, and when we do that, what would we leave behind? Well, we're going to leave behind, what we'll leave behind is going to be x minus 4. So now this first denominator we say is completely factored. Let's factor the second denominator here. Upon inspection, we realize we cannot factor anything out of all three terms. It is a trinomial, an easy type, with a leading coefficient of 1 that does not require the grouping method to factor it. All we need are two factors of positive 16 that sum up to a negative 8. After a little thought, ladies and gentlemen, we will hopefully arrive at the factors of negative 4 and negative 4 as being the proper factors of positive 16 that do sum up to our middle coefficient of negative 8. So therefore, the second denominator factors completely into identical binomial factors, namely x minus 4 and x minus 4. So now that we have both denominators completely factored, we are able to put together our LCD, or least common denominator, of both these rational expressions. In order for our least common denominator to be divisible by the first denominator, ladies and gentlemen, we are going to need a 3 and an x squared. We're going to need that monomial. And in order for our least common denominator to be divisible by both denominators, it's not good enough just to have one factor of x minus 4, but we must have two factors of x minus 4. So you can shorten this up and instead of saying x minus 4 times x minus 4, just say x minus 4 quantity squared. And there you go. That would be your least common denominator of both these rational expressions back up here. So notice the key, first of all, is you always have to make sure your denominators are completely factored before you can begin to think about putting together the appropriate least common denominator. So make sure that you factor completely your denominators. And obviously, we're going to need our Chapter 6 factoring skills to be successful with this. All right, now that we've shown you how to find least common denominators of polynomials, or of rational expressions, we're now going to use this skill, ladies and gentlemen, to begin to add and subtract rational expressions which do or do not have common denominators already. Okay, let's just dive right in here. We'll try to add together a 5 over x and 3 over x. Now, ladies and gentlemen, notice that we are blessed here because we already have a common denominator appearing between both rational expressions. And since we already have a common denominator, we don't have to find a least common denominator. All we have to do is just add our numerators together and place that sum over the common denominator. Hence, our final answer looks like it's going to be 8 over x. And that's it. This is your sum of these two rational expressions. It's 8 over x. And notice this is reduced and in simplest form. All right, let's try another one here. Okay, notice that again we have a least common denominator already appearing, so we don't have to worry about that. All that remains to be done is adding our numerators together. Now these are not like terms, so we cannot literally add them together, so the best we can do to represent this is to say 1 plus x, and we place this over our least common denominator, which is x plus 1. But ladies and gentlemen, notice 1 plus x is the same thing as x plus 1. And hence, To wrap this problem up, we need to reduce this rational expression further. And notice the x plus 1's drop out, and so our final answer is 1. So 1 is the sum of these two rational expressions. That one's done. Let's try another one. Let's try one where we have to subtract. Okay, here we're being asked to subtract two rational expressions, and again, we're lucky because we already have a common denominator. Being the case, we don't have to find a least common denominator, so we just subtract our numerators and place the result over our least common denominator. Well, ladies and gentlemen, we can't stop the problem here. We need to investigate whether this numerator can be factored down, because if it can, it might lead to reduction. So therefore, y squared minus 9, we have to import our factoring skills from chapter 6. Upon doing so, with a little thought, we realize that we have a binomial which represents the difference between two perfect squares, 9 being a perfect square of 3. So y squared minus 9, therefore, factors immediately into y plus 3 times y minus 3. Or you could have these switched around, y minus 3 times y plus 3. And this sits over our common denominator of y plus 3. Now to wrap this problem up, we need to realize that the y plus 3's can reduce out. So we reduce or cancel out these binomial factors between the top and bottom. Our final answer is going to be y minus 3 over 1, or we would just say y minus 3. Whoops. And there you go. So y minus 3 would be the difference between these two rational expressions. And so we are done. Here's another one, x squared over x minus 5. Subtract 10x minus 25 over x minus 5. Notice we are being asked to subtract some rational expressions. They do have a common denominator already, so we don't have to worry about that. So we proceed to subtract our numerators. So therefore we have x squared. And now, ladies and gentlemen, this is a common mistake. We got to make sure that we subtract off this whole numerator, not just the 10x. So you need to subtract off the 10x and the negative 25. Well, subtracting 10x is minus 10x. But subtracting a negative 25 is the same thing as adding a positive 25. Careful these signs. A negative of a negative is a positive. And all this sits over our common denominator. Now, before we call it quits, we need to at least investigate the possibility of our numerator being factored or factorable, because if it is factorable, it might lead to reduction. And so therefore we need to investigate this trinomial. Fortunately, it's an easy type of trinomial to factor, one with a leading coefficient of 1. To factor these types, we discovered that all we need are two factors of the constant term, in this case two factors of positive 25, that sum up to negative 10, the middle coefficient. After some thought, negative 5 and negative 5 are the only factors of positive 25 that do indeed add up or sum up to negative 10. Being the case, ladies and gentlemen, this trinomial factors into identical binomials, namely x minus 5 multiplied by x minus 5, and that sits over our common denominator. Now that our numerator is completely factored, we realize that one of these x minus 5's drop out with our denominator x minus 5. And when we cancel them out or cross them out, we leave behind factors of 1. So our final answer looks like it's going to be x minus 5. And x minus 5 would be the correct difference between these rational expressions. So these problems were all nice because every one of them already had least common denominators present. Now obviously we're not always going to have this luxury. And so now we're going to turn our attention to adding or subtracting rational expressions that do not have a least common denominator. Okay, so we're going to try to add together these rational expressions here, and notice that we do not have a least common denominator present as we did with all the previous problems. Another temptation here, ladies and gentlemen, is to want to cross cancel out the 3's and cross cancel out the y's. that's totally illegal because we're not multiplying these rational expressions together, we're adding them together. So, the first thing you need to do when adding or subtracting rational expressions together is, number one, make sure that all denominators are completely factored. So all denominators must be completely factored. Well, as we're lucky here because y is already completely factored and so is 3. And so there is no need to factor these denominators. So the next step is now we need to find the least common denominator, or the LCD. So now we need to find the least common denominator of y and 3. Well, our least common denominator, if it's to be divisible by both these denominators, must have a 3, and it must have a factor of y. So as it occurs, 3y must be the least common denominator of both these rational expressions. Now the next step is, once we find the least common denominator, we're going to have to build our fractions up into equivalent fractions. So we've got to build our fractions up into equivalent fractions. That's to say that the first rational expression's denominator, being y, is missing the factor of 3. So in order to build 3 over y up into an equivalent fraction that has the least common denominator, we're going to have to multiply the top and bottom of the first rational expression by 3. So top and bottom of the first rational expression gets multiplied by 3. What we're really doing is multiplying 3 over y by 1, 1 being in the form of 3 over 3. And so therefore, our equivalent fraction will obviously be equal to the original fraction. The second rational expression has 3 in its denominators, but it's missing the factor of y. Being the case, we're going to have to multiply top and bottom of the second rational expression by y. Hence, an equivalent fraction of 3 over y is going to be 3 times 3, or 9 over 3y. So 9 over 3y we say is equivalent to 3 over y. These are equivalent fractions, or equivalent rational expressions. Plus, an equivalent rational expression to y over 3 is going to be y times y, or y squared, over 3y. So y squared over 3y is an equivalent rational expression of y over 3. Now that we have a least common denominator present, we just proceed to add our numerators together. So therefore we have 9 plus y squared, and that sits over 3y. We cannot factor the numerator because it is the sum of perfect squares, and we already indicated weeks ago that the sum of perfect squares cannot be factored, only the difference of squares. And so therefore we cannot factor 9 plus y squared, and so since the numerator cannot be factored, there is no reducing we can do between the top and bottom here. I mean, we could split this up and put the 9 over the 3y and the y squared over the 3y and didn't do some reducing, but we don't normally do that in this case, ladies and gentlemen. We call this quits. This is our final answer, our sum of these two rational expressions. Okay, let's try another one. We're going to take x over x minus 3, and to that we're going to try to add the rational expression 1 over 3. First of all, we have to make sure that all our denominators are completely factored, and they are. You cannot further factor x minus 3 or 3, and so now it's time to put together the least common denominator. So the least common denominator of both these rational expressions has to have a lone factor of 3 in it, and it also has to have the binomial factor of x minus 3. Now that we've identified a least common denominator, what remains is to build these fractions up into equivalent fractions that both take on the LCD. The first fraction has the x minus 3 in its denominator, but it's missing the factor of 3. Being the case, top and bottom of the first rational expression is going to have to get multiplied by 3. The second rational expression's denominator has only 3, but it's missing the factor of x minus 3. That being the case, top and bottom of the second rational expression gets multiplied by x minus 3 to build it up into an equivalent fraction that has the least common denominator. So an equivalent fraction of x over x minus 3 is going to be 3x over 3 times x minus 3. We say that this rational expression here is equivalent to the x over x minus 3. Plus, an equivalent rational expression of 1/3 is going to be 1 times x minus 3, or x minus 3, over 3 times x minus 3. This rational expression is equivalent to our original rational expression of 1/3. Now that we have a common denominator, what remains is to actually add our numerators together. So we have 3x, that is to be added to x minus 3. And all this is going to sit over our least common denominator. Well, combining like terms in the numerator, 3x plus 1x is 4x, so we have 4x minus 3, and that sits over our least common denominator. Notice we cannot factor the numerator in any way, shape, or form, and the denominator is completely factored. Being the case, there is no more reducing we can do between the numerator and denominator, and therefore, ladies and gentlemen, this is your final answer, or sum of these two rational expressions. That one is done. We'll try a subtraction problem now. 3x plus 1 over 2x minus 6. And we're going to subtract off the rational expression of x plus 2 that sits over x minus 3. First, we have to make sure both the denominators are completely factored before we can begin to put together a least common denominator. Notice the first denominator is 2x minus 6, and we ask ourselves, can we factor 2x minus 6? Well, notice we can factor 2 out of both the first two terms, and therefore factoring 2 out of these two terms, what would we leave behind? Well, we're going to leave behind 2 times x minus 3. So therefore, 2 times x minus 3 is the complete factorization of 2x minus 6. Notice the second denominator cannot be factored in any way, so it already is completely factored. Just bring it along. And now that our denominators are completely factored, we can put together our least common denominator. And our LCD is, if it's to be divisible by both these denominators, must have a factor of 2, and it must have the binomial factor of x minus 3. And so there you go, ladies and gentlemen, that would be your least common denominator of both these denominators for both these rational expressions. The next step now is to build these fractions up into equivalent fractions where both denominators become the least common denominator. Well, notice the first rational expression already has the least common denominator, so we don't have to do anything to our first rational expression. Just bring it down. So we just bring it on down. The second rational expression's denominator has the x minus 3, but it's missing a factor of 2. Being the case, top and bottom of the second rational expression is going to have to get multiplied by 2. Hence, we have 3x plus 1, and that sits over 2 times quantity x minus 3, minus 2 times quantity x plus 2, which sits over x minus 3. Now, ladies and gentlemen, notice, over 2 times x minus 3. Notice now that we've successfully built both rational expressions up into equivalent rational expressions that both contain the least common denominator. All that remains now is simplifying our numerator here. So therefore we have 3x plus 1 minus sign, just bring the minus sign down, 2 times quantity x plus 2, and all this sits over our least common denominator. Further simplifying the numerator, we're going to have to use our distributive property and take the factor of negative 2 into both terms inside the parentheses. Hence, we're going to have 3x plus 1 Negative 2 multiplied by x is minus 2x. Negative 2 multiplied by 2 is a minus 4. And all this sits over our least common denominator. Combining like terms up in the numerator, we have 3x subtract 2x is going to be 1x. And 1 minus 4, 1 minus 4 is minus 3. So this is how our numerator simplifies, and notice now, ladies and gentlemen, the last move here is we can reduce the x minus 3 in the numerator with the x minus 3 factor in the denominator. So they reduce out, and when we do so, we leave behind factors of 1. So our final answer is going to be 1 over 2, 1/2. So 1/2 is the final difference between these two rational expressions up here. And notice I showed all the steps. Please do show all steps. That keeps you out of trouble and stays off silly mistakes. Okay. You'll notice as we go, through some of these problems require a lot of steps and quite a bit of paper. All right, let's try one here. Let's try to add 5 over a to 20 over a squared minus 4a. Step number 1 is we have to make sure that all these denominators are completely factored. And notice a is already completely factored, but this a squared minus 4a can be factored and needs to be factored. To factor the second denominator, we should realize that we can factor an a out of both terms here. And so this factor the a out, there it is, times what do we leave behind in doing so? When you factor an a out of a squared, you leave behind an a, minus when you factor a out of 4a, you leave behind 4. Now this denominator has been completely factored. That being the case, we can now easily put together our least common denominator. Our least common denominator is going to need a factor of a, and it's also going to need the binomial factor of a minus 4. So this would be your least common denominator of both these denominators. What remains now is to build both these rational expressions up into equivalent rational expressions that take on the least common denominator. The first denominator has the factor of a, but it's missing the factor of a minus 4. And because it's missing a minus 4, top and bottom of the first rational expression has to get multiplied by a minus 4. The second rational expression has the a, and it also has the factor of a minus 4. So the second rational expression already has the least common denominator, and that being the case, we don't have to do anything to it. We're good. Just bring it on down. Now that both of our rational expressions have a common denominator, all that remains is simplifying our numerator. So to simplify the first numerator here, well, tell you what, let's just write it like this. Let's just now add these numerators together and place this result over our least common denominator. Now we're going to have to distribute the 5. So 5 times a is 5a, minus 5 times 4 is 20, over your common denominator. Combining like terms in the numerator, notice the 20s drop out, negative 20 plus 20, add up to 0. So the 20s cancel out, leaving us with just 5a. And now what remains here, ladies and gentlemen, to wrap this problem up is notice this factor of a in both the numerator and denominator can be reduced out. So a divides into itself once, a divides into this a down here once. Final answer is going to be 5 over a minus 4. And we're done. And that's your final answer. So 5 over a minus 4 is the sum of these two rational expressions we started with back up here. Okay, I'll show you one more here. Try to subtract 4y over y squared plus 6y plus 5. And we're going to subtract off 3y over this trinomial, y squared plus 5y plus 4. Notice these trinomials are not identical. Being the case, they're not the same denominator. So we're going to have to ultimately find the least common denominator for both these rational expressions. But in order to do so, we're going to first of all have to make sure we completely factor each of these denominators. So notice to factor this first denominator, which is a trinomial, fortunately an easy type of trinomial, one with a leading coefficient of 1. All we need are two factors of the constant term positive 5 that sum up to the middle coefficient of positive 6. The only factors of 5 that add up to 6 would be 1 and 5. So this first denominator factors into the product of these two binomials, y plus 1 multiplied by y plus 5. Again, the 1 comes from here and the 5 comes from here. The second denominator also is an easy type of trinomial to factor, one with the leading coefficient of 1. All we need are two factors of positive 4 that sum up to positive 5, the middle coefficient. After some thought, the only factors of 4 that add up to 5 would be 1 and 4. Hence, to factor this trinomial now is pretty simple. It's just going to be the product of the two binomials of y plus 1 multiplied by y plus 4. 1 goes here, 4 goes here. Now that we've completely factored both our denominators, we can easily put together our least common denominator. In order to be divisible by both these denominators, our least common denominator is going to have a factor of y plus 1. Now, you don't say two factors of y plus 1 because there's only one factor of y plus 1 between the separate denominators. So we only need one factor of y plus 1. We're going to need a factor of y plus 5. But that's not all, ladies and gentlemen. We're also going to need one factor of y plus 4. So therefore, this is our entire least common denominator of both these denominators here. Now we have to build both these fractions up into equivalent fractions that both take on this least common denominator. Notice the first denominator has the y plus 1 and the y plus 5. It's got the y plus 1 and y plus 5. It's missing a factor of y plus 4. Being the case, we're going to have to multiply top and bottom of the first rational expression by y plus 4. Notice now our first rational expression does have the least common denominator. Minus. The second fraction's denominator has the y plus 1. It's got this. It's got the y plus 4. It has this. It's missing y plus 5. Because this denominator here is missing y plus 5, we must multiply top and bottom of this rational expression by y plus 5. Now, this rational expression has the least common denominator. Notice now both of our rational expressions do possess the least common denominator. That being the case, all that remains is simplifying our numerators here. And so I'm going to subtract off the second numerator over here. And all of this sits over our least common denominator. Okay, what we need to do is distribute here, and we're going to have to distribute here. So 4y multiplied by y is 4y squared, plus 4y multiplied by 4 is 16y. Now we're going to distribute a negative 3y into both these terms. So a negative 3y multiplied by y is going to be negative 3y squared. Negative 3y squared. A negative 3y multiplied by 5 is going to be a negative 15y. Negative 3y multiplied by 5 is negative 15y. And all this sits over our least common denominator. Further simplifying our numerator by combining like terms, we have a 4y squared that must subtract off a 3y squared, and 4 minus 3 is 1. So 4y squared minus 3y squared is 1y squared, or just y squared. And then we have a 16y that must subtract off of 15y. 16y minus 15y is 1y, or y. And all this sits over, you guessed it, our least common denominator. One last move now, ladies and gentlemen, is that notice our numerator can be factored, and you need to at least entertain that situation because it might lead to reduction. So let's try to factor our numerator. Notice we can factor y out of both terms. There it is. Times, what would we leave behind in doing so? We would leave behind y plus 1. Y times y is y squared. Y times 1 is y. And this sits over, you guessed it, our least common denominator. One last move now is to realize that we need to reduce this rational expression. The y plus 1's reduce out. So our final answer to this problem is going to be y times 1, or y, over y plus 5 multiplied by y plus 4. Finally done. This is your final answer. So there you go. This is the final answer, ladies and gentlemen, right here, for having subtracted these rational expressions here. Notice the length of this problem. Notice all the steps that were necessary to show in order to get to the eventual final answer. So if nothing else, we're learning that these problems just require a lot of patience. A lot of patience and perseverance, ladies and gentlemen, and a lot of practice. You will get better at these problems. Okay, so that concludes section 7.3. Stay tuned, and I will do 7.5 in a moment.